I have spoken frequently in this space about the aerosol masking effect. This video provides a short summary and an update. The latter is based on an article at The Conversation written by a postdoctoral research fellow at the University of Washington. First, the short summary of the aerosol masking effect. Just as industrial activity produces greenhouse gases that trap heat, industrial activity also produces small particles that reflect back into space some of the incoming sunlight. These tiny particles are called aerosols, and they reflect incoming sunlight before this incoming radiation can be used to heat Earth. As I have mentioned frequently in this space, Professor James E. Hansen has pointed out in many interviews and peer-reviewed papers that the aerosols produced by industrial activity fall out of the atmosphere in about 5 days. If industrial activity were to suddenly stop, then the planet would heat very rapidly. Hansen calls this our Faustian bargain. I have referred to it as the best-kept secret in climate science because it is seldom mentioned by political figures, media personalities, or paid climate scientists. A peer-reviewed open-access paper published in Geophysical Research Letters on July 10, 2019, indicates that the loss of aerosol masking would produce an enormous impact based only on reduced albedo, or reflectance, not including factors such as increased methane being released into the atmosphere. The abstract of the paper points out that, quote, this is equivalent to the effect of 1 trillion tons of CO2 emissions, end quote. This, quote, would hasten global warming by an estimated 25 years, end quote. A peer-reviewed open-access paper published June 15, 2021 in Nature Communications indicates that loss of aerosol masking would lead to much higher radiative forcing than indicated by previous research. Specifically, radiative forcing would increase by 55% globally. Worse yet, radiative forcing would increase by 133% over land, where most of us live. According to governments of the world, we have already eclipsed the 2C Rubicon. Adding an additional 133% to the existing level of radiative forcing would take Earth quickly to 4.67 C. As I have mentioned several times in this space, the rapid rate of environmental change from about 2C to more than 4.5 C above the 1750 baseline would be catastrophic for life on Earth. I doubt any species could keep up with such a rapid rate of environmental change, and human animals are especially poorly suited for such a rapid change to the place we call home. I now turn to the update written by a postdoctoral research fellow at the University of Washington, titled The World Regulated Sulfur in Ship Fuels and the Lightning Stopped. This article was published on March 11, 2025. If you are familiar with the aerosol masking effect, the first 3 paragraphs tell the story. Quote, if you look at a map of lightning near the port of Singapore, you'll notice an odd streak of intense lightning activity right over the busiest shipping lane in the world. As it turns out, the lightning really is responding to the ships, or rather, the tiny particles they emit. Using data from a global lightning detection network, my colleagues and I have been studying how exhaust plumes from ships are associated with an increase in the frequency of lightning. For decades, ship emissions steadily rose as increasing global trade drove higher ship traffic. Then, in 2020, new international regulations cut ships' sulfur emissions by 77%. Our newly published research shows how lightning over shipping lanes dropped by half almost overnight after the regulations went into effect. End quote. The second paragraph includes an embedded link to a peer-reviewed open-access paper published in Geophysical Research Letters on September 7, 2017. Written by 4 scholars, this paper is titled Lightning Enhancement Over Major Oceanic Shipping Lanes. The first 2 sentences of the abstract provide a good overview. Quote, using 12 years of high-resolution global lightning stroke data from the Worldwide Lightning Location Network, we show that lightning density is enhanced by up to a factor of 2 directly over shipping lanes in the northeastern Indian Ocean and the South China Sea as compared to adjacent areas with similar climatological characteristics. The lightning enhancement is most prominent during the convectively active season, November to April for the Indian Ocean and April to December in the South China Sea, and has been detectable from at least 2005 to the present. End quote. The abstract is followed by 3 key points. 1, quote, lightning is enhanced by about a factor of 2 directly over 2 of the busiest shipping lanes in the Indian Ocean and South China Sea, end quote. 2, quote, environmental factors such as convergence, sea surface temperature, or atmospheric stability do not explain the enhancement, end quote. 3, quote, we hypothesize that ship exhaust particles change storm cloud microphysics, causing enhanced condensate in the mixed phase region and lightning, end quote. A plain language summary reiterates the information found in the abstract and key points. Here's the lead. Quote, lightning results from strong storms lifting cloud tops up to high altitudes where freezing occurs, and collisions between drops, grapple, and ice crystals lead to electrification, end quote. I include the lead not because it provides significant additional information, but because it mentions my favorite form of precipitation, grapple. According to the Merriam-Webster Online Dictionary, grapple is, quote, granular snow pellets. It is also called soft hail. As I indicated at the beginning of this video, the update I'm providing here is based on an article at The Conversation, written by a postdoctoral research fellow at the University of Washington. Under a section titled Ship Emissions and Lightning, we find 2 important paragraphs. Quote, with engines that are often 3 stories tall and burn viscous fuel oil, ships traveling into and out of ports emit copious quantities of soot and sulfur particles. The shipping lanes near the port of Singapore are the most highly trafficked in the world. Roughly 20% of the world's bunkering oil used by ships is purchased there. In order to limit toxicity to people near ports, the International Maritime Organization, a United Nations agency that oversees shipping rules and security, began regulating sulfur emissions in 2020. At the port of Singapore, the sales of high-sulfur fuel plummeted from nearly 100% of ship fuel before the regulation to 25% after, replaced by low-sulfur fuels, end quote. 5 paragraphs later, we find a review of this research. Quote, in our latest study, my colleagues and I describe how lightning over the shipping lane fell by about 50% after 2020. There were no other factors, such as El Niño influences or changes in thunderstorm frequency, that could explain the sudden drop in lightning activity. We concluded that the lightning activity had fallen because of the regulation. The reduction of sulfur in ship fuels meant fewer seeds for water droplet condensation and, as a result, fewer charging collisions between the ice crystals. Ultimately, there have been fewer storms that are sufficiently electrified to produce a lightning strike, end quote. The aerosol masking effect is well described by this article in The Conversation. It reiterates the negative effects that result from well-intentioned regulations. It leaves us with a conundrum. Obviously, clean air is important. Equally obviously, if you're paying attention, clean air has unintended negative impacts. Although we need clean air for our continued survival, we also need rainwater. This recent research manages to differentiate between lightning and rain. It points out that fewer particles in the atmosphere result in fewer lightning strikes. This result is beneficial to everyone except wildland firefighters seeking more overtime pay. Lightning might be an indicator of more aerosols in the atmosphere, although confirmation will require additional research. In any event, the ability to distinguish between lightning and rain is a significant outcome and an indicator that we occupy a complex world.